All right, so we're back here. This is going to be the third part, the last part. We're going to do two more examples, and then I'm going to show you one extra thing. If we take 16, now this is where I would not want to complete the square. And the reason is I don't have a 1x squared. To be able to complete the square, this has to be a 1x squared. So I would first have to divide everything by 2. And this would be x squared minus 5 over 2 times x plus something equals 12 over 2, that's a 12, that would be positive 6, plus the same thing. So you can see it's going to start getting messy if I have fractions already. To complete the square, we have to take half of this, divide by 2. Now that would be negative 5 over 4. When we take half of negative 5 over 2, we'd get negative 5 over 4. We would square that, and this is 25 over 16. All right, now we can factor this. That would be x minus 5 over 4. Okay, that factor squared equals common denominator to get 16, I would do 6 times 16, so 96 over 16 plus 25 over 16 is 121 over 16. Okay, that's kind of messy, but actually it's nice because in this case, these are both perfect squares, so we would get x minus 5 over 4 equals plus or minus. This is 11, and the square root of 16 is 4. Then we would add 5/4 to both sides, and we would get x equals 5 over 4 plus or minus 11 over 4. Now we wouldn't leave that in this format because we can simplify 5 over 4 minus 11 over 4, and then 5 over 4 plus 11 over 4. This would be negative 6 over 4. This would be 16 over 4. And that would be equal to negative 3/2. I always simplify a fraction, and that's positive 4. But to be honest, we could have factored this, and it probably would have been a lot easier. We'll do one more example here. We're going to do 20. Now 20 is actually set up really nicely for completing the square. It's a 1r squared plus 12r plus something equals negative 36. That's a 36 plus something. We would divide by 2 and then square that. So 36 is our magic number here. Now this is a perfect square trinomial, so we will write that as a binomial, the binomial factor squared, equals, and this adds up to 0. So what happens here, we still take the square root, but we get r plus 6 equals, now plus or minus 0, I mean we can write it like that, but when we subtract the 6, negative 6 plus 0 is the same as negative 6 minus 0. So basically we can just ignore this, and what we get is one solution. R is equal to negative 6. This is a case where in this problem here, we only get one solution. Now with the quadratic formula, the connection there is that in the quadratic formula, the opposite of b plus or minus the square root b squared minus 4ac all over 2a, we end up getting one solution when this value here is equal to 0. When the discriminant is 0, in that case, because plus or minus 0 is still one answer. All right, so again, is this the way that I would necessarily want to solve these? Probably not. This one here, I would have factored it. And even if I couldn't factor, I think it's probably easier to use quadratic formula. But one of the reasons why I'm showing you this, it'll come up if you study what's called conic sections, but we can also use this. I'm going to ignore here. And I'm going to do one more problem that I'm writing down here. Solve ax squared plus bx plus c is equal to 0. Now this represents any quadratic equation. Any quadratic is going to be in this form. A, b, and c are real numbers. Okay, if I wanted to complete the square, solve this by completing the square. First move here, I have to have a 1x squared. So we divide everything on both sides of the equation by a. And so we'll get x squared plus, we'll have a fraction, b over ax plus c over a equals 0. 0 divided by anything is still 0. Now this is a constant, it's some number. That has to move to the other side. So we'll subtract that. X squared plus b over a x equals negative c over a. Now we're going to complete the square though, so we will add the same thing to both sides. To complete the square, we take this middle term here, we divide it by 2. Now that would be b over 2a, and then we have to square that. And so we would get b squared over, when we square 2a, that would become 4a squared. So b squared over 4a squared, this is kind of messy, but it'll start to get a little bit nicer. This is a perfect square trinomial, which we can now factor. It would be x plus b over 2a squared equals, now let's go ahead and combine. Let's add this fraction. So 4a squared, I can make this a 4a squared by multiplying by 4a. So I'm going to take that fraction, numerator and denominator. This would become negative c times 4a. I'm going to write that as negative 4ac over 4a squared plus b squared over 4a squared. Now we can add the numerators. So it's this plus this. Now I can't combine it into one term, but I can still write it as this plus this, or what I'll do is actually write the b squared first. So b squared minus 4ac. Ooh, that should actually look kind of familiar to you. Over 4a squared. All right, now we're not done solving. We're not done until we get to x equals. This is a perfect square. We can undo that by taking the square root of both sides. So we get x plus b over 2a, because the square root of a square just leaves us with this, equals. Now I'm going to take the square root of the numerator and the denominator separately. The numerator, I can't do anything with that, but the denominator is actually a perfect square. The square root of 4a squared is 2a. So I don't need the square root anymore because I can simplify this. Remember though, we always have two solutions. We have to have plus or minus. We have to account for both possibilities. All right, now we're almost done here. We want to move the b over 2a to the other side, so we subtract it. Minus b over 2a. I'm going to come up here. We get x equals negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And because we have a common denominator, we can now add our numerators, and we get x equals the opposite of b, plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. And what we have just done is we just proved the quadratic formula for any quadratic of this form. And this is why we have to have it set equal to 0. This is the equation or the formula that you can just plug in the values for a and b and c, and what you will get are the answers to this quadratic equation. This is not magic because we actually proved that it must be true. The way we prove that this is always the case for a quadratic is by completing the square. And that is the end of the notes.